Okay, in section U2A5 of this course, they go through centripetal force calculations. Now what you'll notice is that this is U2A5b. So in U2A5a, what I tried to do was explain something about centripetal forces, and it's hard for people to get their head around this. If you have a string and you have a weight on it and you spin it in a circle, picture this, or actually do it, you can feel the tension on the string. A lot of people intuitively would think that the tension is going outwards. It's not. You are pulling it inwards, and that's why it continues to go in a circle. So that's your force of tension, and acceleration centripetal always follows the tension. If we cut the string, the velocity would go in this direction. Now, the next thing I want to get straight when we do calculations is we always have to set what positive and minus is. So, for example, as physicists, we say positive is to the east, negative is to the west. It doesn't have to be, it's just what we say. When we're doing these problems, we have to set a positive and negative direction. So, let's say you're spinning around a weight and you're at the top of a circle. Now, I believe in all these questions, you'll either be at the top or at the bottom. If you're at the top of the circle, gravity is going down, and tension is going down towards the middle. In physics, in centripetal calculations, anything that's going inside of the circle, so anything that's going down towards the middle, is positive. Now, on the other hand, if the weight was now at the bottom, the tension is still going towards the middle. Remember, in centripetal forces, that tension, you're pulling that towards the middle. But gravity is going down outside of the circle because gravity always goes down, and therefore the gravity would be negative. Positive, positive, two forces on something that's in centripetal force. Positive, negative if that same weight is in its travel is at the bottom. So let's derive a formula. I highly suggest that you watch my first video, U2A5a, to understand centripetal force. I highly suggest you understand my second video because I think my calculations are going to simplify things for you. Force equals mass times acceleration. What I do is I rearrange this formula first to say that acceleration equals force over mass. We have said that in centripetal studies, acceleration is equal to v squared over r. So I'm going to substitute that in. Now, this is radius in meters. This is velocity in meters per second. And now what I'm going to do is I'm going to put a mass in here. When our mass is at the top of the circle, what we say is we say that our force of tension, because our force is our net force, so our force is made up of two different forces. Our force of tension is positive, plus our force of gravity. So now, what can we calculate from one of these questions? We can calculate force of tension, we can calculate force of gravity, we can calculate mass, radius of the rope, or the velocity at which it's traveling. And remember, velocity is always going like this. So if we were at these different positions in travels, we would be like this. We can calculate acceleration if we want. So this one formula will allow us to calculate all these different things. Now, if the weight that's on the string is at the bottom of its travels, v squared over r equals force of tension minus force of gravity over mass. You're going to see a lot of formulas and a lot of calculations, but in my mind, I think you can get everything you need using this, and this. Now, There's a couple of more points to get straight. So have these three formulas ready to go. So I'm hoping you can follow the bouncing ball here because there's another calculation. If we have something that's in centripetal motion, the trip around here, let's say it took 3 seconds. T equals 3 seconds. T is your period. It's the time for one trip around here. The frequency would be 1 over T. So that would be 3.33 hertz. So the unit for period is second. The unit for frequency is hertz. Period equals 1 over frequency if they give you the frequency. And frequency equals 1 over period if they give you the period. Okay, so these are different calculations that they ask you to do. The very last thing I want to point out is you can use these centripetal formulas for cars traveling through a valley. It's the exact same thing. We still use these formulas up here. This is going down at the bottom of its trip around the circle. Or we could use these for a car that's going over a hill. We still have the force of tension pulling down. We still have gravity pulling down. So these same formulas still hold true. I believe they'll work. Give Unit 2, Activity 5 a go. If there are difficulties, please contact me and I'll try and straighten out any misconceptions or anything that I may have done wrong here.